All right, so now we're going to take a look at problem number 2, and we're going to split this up into 2 pieces. So what we're saying, actually 3, so what we're saying is this elevator is going to accelerate to 5 meters per second, and then decelerate, and it's going to cover 190 meters, but we have a little bit of a problem, which is we know we have got a total of 190 meters, but we're going to split this trip into 3 pieces. We're going to have an accelerating part, we're going to have a constant velocity part, and then we're going to have a decelerating part. The reason is we can only accelerate for a little bit of time until we get back, when we get up to 5 meters per second. And then we're stuck at that speed. We can't go any faster. So to keep that in mind, I'm just going to split this problem into 3 pieces and take a look at the accelerating part in this video and then the constant part in the next. So I'm going to say here, I don't know what distance I'm going to be at when I get up to 5 meters per second, but I do know that my speed will be 5 meters per second. I know that my position is 0. I know that my initial velocity is 0. So I don't know my time, but I do know my acceleration is 1.22 meters per second squared. So for this first part, let's just get the numbers that we can get here. We want to know how far it moves while accelerating, and we want to know how long it takes to make the run. We'll worry about that eventually, but right now I just want to solve for what I can solve for. So with that in mind, let me pick a formula. Let's try this one. X equals 1/2 at squared plus v naught t plus x naught. So x equals 1/2 times 1.22 times t squared plus 0 times t plus 0. 2 equations, 2 unknowns. So this formula is not helpful to us. That doesn't mean we give up. It means that we go ahead and try the second formula. Let's try this one. V equals at plus v naught. So I'm going to get 5 equals 1.22 times t plus 0. And that's going to give me a time of 4.09 seconds. Great. Now, based on that, maybe we can figure out how far it goes while making this acceleration happen. So we go back and we plug in, and we're going to get x equals 1/2 times a times 4.09 squared. And when we solve for x, what we end up getting is 10.2 meters. All right, so that's the first part. We'll do the next 2 parts in the next video.